Hello, everybody, and welcome back to the Omnichannel X podcast. I'm Noz Urbina, your host and principal consultant at Urbina Consulting. I am very happy to bring you this conversation with Ilya Venger, principal product lead for industry AI at Microsoft. You know, everywhere I go these days talking about AI, businesses are asking the same questions. We need to implement AI, but where do we even start? How can I make sure my AI doesn't hallucinate? Should I train my AI or can I just use an off-the-shelf model? And generally, how do we avoid the pitfalls that come with racing into AI without a strategy? Today, we're diving deep into exactly that. Ilya brings a wealth of knowledge and perspective from the front lines of enterprise AI implementation. In a previous role, he built UBS's enterprise knowledge graph and is now leading global teams at Microsoft delivering generative AI solutions across multiple industries. He's seen what works, what doesn't, and why. A knowledge graph, by the way, if you're not familiar, is the fastest growing type of database in the world because it is a database that models knowledge in the ways that humans do. It's as a series of interlinked concepts rather than just tables and rows like you would get in a regular database. If you want to learn more, there's an article defining it on the Urbina Consulting and OmniX blogs. It was one of our first glossary entries, which we hope to be adding lots more of. We'll link to that in the show notes, and do let us know if there are other terms that you would like a friendly definition for. In this episode, we get into the nitty-gritty of AI implementation. We talk about why one of my favorite metaphors of treating AI like an army of eager but inexperienced interns is probably the right mental model. And we talk about how to identify where AI actually adds value versus when it's just a shiny distraction, and why the 80-20 rule of AI performance is something every business needs to understand. How do we take advantage of the 80 or 90, 95% success rate and deal with generative AI's tendency for inconsistency in the rest? We also tackle some tough questions about when to fine-tune models versus off-the-shelf solutions, how to prepare your data landscape for AI success, and why knowledge graphs might be the missing piece in your AI strategy. I mentioned knowledge graphs earlier. They are becoming one of the go-to tools for making sure that AI works properly. Neither Ilya or I like to pull punches about the challenges with AI, so we're going to discuss understanding AI's failure modes, which will help you work around them and build robust AI processes, the problems with outdated data, and why throwing AI at a problem without re-engineering your process is like building a horseless carriage instead of car. Whether you're a business or team leader, an experienced designer or content strategist, or anyone trying to make sense of how AI fits into your organization's future, this conversation will have some practical insights and tips from someone who has been in the trenches. So I'm calling this discussion Beyond Magic Promises, Implementing Productive AI. Hello, everybody. Welcome to this episode of the Omnichannel X podcast. Thank you for joining us again, or welcome if this is your first time. If you don't know me, my name is Noz Urbina. I am founder of Urbina Consulting, your podcast host, and a very enthusiastic person who's going to be talking to Ilya Venger today, principal product lead for industry AI at Microsoft. Here at the Omnichannel X podcast, we explore how organizations can build better relationships with their audiences using content design, governance, and systems. So of course, we talk a lot of strategy and emerging technologies, which means plenty of AI. And Ilya is a PhD in systems biology and bioinformatics from the Weizmann Institute. And he was previously executive director at UBS, where he built the enterprise knowledge graph Helix, and currently leads global teams delivering generative AI platform solutions across Microsoft's industry clouds, and is focusing today on best practices and implementations for businesses implementing AI. So he's a perfect person to be on Omnichannel X. So Ilya, anything else you want to add about yourself?
Very excited to be here. Thanks for inviting me. Last 4 years at Microsoft, so very interesting times, as we all know. Working first in classical machine learning and now incorporating Gen AI for the last 2-3 years. Very interesting journey with a lot of different customers from different industries, starting from retail, manufacturing, healthcare, financial services. As you said, we're Microsoft Industry Cloud, so there's multiple different industries and industry-specific solutions that we are delivering in those areas.
So Ilya, to kick us off, many businesses feel pressure to implement AI, but don't know where to start. This is one of my favorite questions. So, where should AI fit in existing workflows? So, there's a lot of talk about people replacement and so on, but I think it's good to talk about whatever we're doing, we're going to be placing it into human workflows as well. So, how do we make this integration work?
Yeah, I think implementing AI for the sake of implementing AI is the wrong approach, right? That's the beginning. Yes, you want to implement AI because you want the shiny toys, but really you need to understand what business value you're trying to drive with your business and where it could help you. One of the most important things that we do as we are getting into all of our customer engagements is starting to understand, okay, what are the main pain points? Where can you see some automation or some augmentation of your people? Where can it be helpful? And then looking at the specific processes in which people participate. And then one of the ways in which we're looking right now, and the models have been improving significantly, and the tooling around the models has been improving over the last few years, right? It started with very simple chatbots, and we started adding a little bit of, okay, grounding in your documents and memory, and now we're talking about agentic flows that are self-correcting at times. I think one of the ways to look at your problems today is saying, okay, where can I add or in where in my process I can add an eager but relatively junior person. And the best thing to think about is, yeah, we don't want to necessarily replace the junior people. It's actually where could you, if I had a little army of juniors that have something to do within my process, where would I put them such that I achieve my business results? And then so you need to look at your processes. So this is where you start. Okay, so identify the problem, identify the process, which processes you have, and then which points in those processes will not necessarily laborious, but where you could augment the process and improve it significantly.
I'm smiling myself silly here because for 2 years I've been using exactly the same metaphor. I called it the 10,000 interns.
Yeah,
So,
yeah,
if someone gave you the army of 10,000 interns, how would you put them to work?
amazing.
Some
Yeah,
people get offended because they feel like I'm actually speaking badly of interns. But I think that this talks to the, how do I put this delicately, speaking to a leader in AI from Microsoft, the quality problem.
it's a real problem, I think. So
Yeah, no, it's good. And we need to be able to talk about it openly and honestly. The way that I like to talk about it is that if you create a knowledge flow in your organization, a knowledge worker flow in your organization that has zero robustness for
mhm.
error, that's a bad flow.
Yeah,
You've
exactly.
designed a bad process. If no one can make any mistakes, you have designed a bad process. That's not on the entities involved. So if they're artificial or human and they make mistakes, your flow has to be able to cater for that. Although we are looking for automation opportunities in a sense, because we're putting in machines to do things, we're looking for automation opportunities that still have some robustness. So we've talked about people throw out different percentages, like the 80% almost works, 95%, etc. How should we approach this gap?
Yep. So first of all, I think, so, and again, this is how we've been working, is build out the 80%, right? So build it out and not just as a POC, because yes, the POCs actually usually work at 100%, just on a very simple problem that is the happy path that is not taking you all the way. So the way that I would think about this is, okay, build your 80%, identify what the 20% is, and then start thinking, because this is the point where you need to start really thinking, and then you've got multiple different ways to analyze the problem, and you actually need to perform some analysis. It's like one option is, okay, let's start pushing my AI to be better in this particular task. It might work, it might bring you to 95, sometimes to 99% quality, and which might be sufficient for your use case. The important thing there is to identify which part of the process fails, because alternatively, what you should be doing is saying, and this is where we're eventually are going to go. Right now, we're adding AI into existing processes, which is not great because we're inventing horseless carriages instead of cars. So what you really want is you want eventually to re-engineer your process, and not just one process. You want to re-engineer your whole organizational interwoven process matrix, right? So one opportunity to look at is, okay, so here's the 80%, this works. How should I be changing my process in order to accommodate for that slack? And then because maybe the 20% you actually could completely get rid of.
Let's stop and define the problem a little bit here.
Mm-hmm.
So when we say 80%, 20%, So 20% of the time it doesn't work. So it
Yeah.
fails in some way. So I think what we need to talk about is, or what we want, if we're going to define our terms, let's talk about different failure modes. Why does it go
Hmm.
wrong? How can it go wrong? And then what
Yeah.
I've also noticed is with when I'm giving, for example, AI trainings, is people, if you're new to the technology, the failure modes seem alien because we're used to working with
Correct.
computers. We're used to working with computers, so I say, look this up or tell me this thing, and it either does or doesn't. Like it bugs or it returns no answer, etc. Whereas these are machines that can return wrong answers or non-existent answers. So what are the failure modes that could be in the 20%, and how do people familiarize yourselves? So when you say analyze that, I think that in that of understanding the failure modes and understanding how these things operate differently, I think we need to talk to that a little bit.
Okay. So let's cover two things. I think when I said, okay, put in your machine and see what your baseline is, right? What's the 80%? You need also to start. Very often we have no evaluations. When you first come into your customer with a product, you throw together some POC. As I said, the POC probably works 100% on something very small, and you actually haven't put in evaluations in place. So one of the most important things is to, in order to understand what failures modes you have, you need to have some baseline and you need to have some evaluation of what good looks like and what is the actual delta between what is expected and what you're actually getting out of the box. Now, another point I want to say is, and it refers to your point around that the modes of failure are new, right? The mode of failure, because I expect my machine to answer perfectly, right? Because we used to have deterministic programs that are running and that are defining the outcome very robustly. So this is one mode of failure when the machine underperforms because it just makes a standard error. But we also need to remember that the errors that it makes, and we tend to anthropomorphize our AI assistant, right? We know that we as humans are very good at anthropomorphizing. And the modes of failures are also not the same as an intern, right? They are inhuman, they are alien from that perspective. So you also need to identify the type and then say, okay, is this something that a human would do, or is it not something that a mistake that a human would do, right? It's like a human would usually not, for example, one common mode of failure with RAG systems, with retrieval augmented generation, when we want to get a bunch of documents and then we want our agent to answer based on these documents, is confusion, it's like semantic confusion, right? Because it takes something from one document, something from another document, and then it connects it in a way that no human would. It's like it's not necessarily a hallucination. People hallucinate all the time, right? People make up stuff continuously.
I don't think there's
Actually,
anybody who hasn't had a false memory. If we're tired or whatever, emotional, lots of us will remember things differently as someone else.
that's a good one. Yeah.
I think there's two things. So we anthropomorphize the machines, and then we also idealize the humans. So
Yes.
there's, for me, there's an overlap there in the sense that we pretend. I had literally this dialogue on LinkedIn where someone said, if a lawyer couldn't give you the same answer twice, then you would fire them. And I said, there's no lawyer on the planet who could literally give you the same answer twice. When a human gives you an answer, they're not doing a lookup in a database. So if I gave you an answer that was even as few sentences long and you came back an hour later and asked me to reproduce it, I couldn't.
Let me give you another one, is that if I go to a lawyer, I go to lawyer A and they will give me one answer. I'll go to lawyer B and they will give me another answer. That doesn't mean that I need to fire all lawyers, right? Because lawyers sometimes disagree between each other, or doctors that have opinion A and opinion B. You actually go and get a second opinion with a medical professional, right? That is very, very
Yes.
common.
Opinion or interpretation of the same facts.
Yeah, yeah.
So you mentioned the word probabilistic. No, you mentioned the word deterministic. So we'll
Neither of
make
it.
this kind of distinction here. So we're used to programs that are deterministic, that some
Correct.
human determined how they should work and gave them particular rules, determining rules where they come to some sort of conclusion, which is why when they cannot determine something, they just bug, like they just
Mm-hmm.
cannot return an answer, they fail.
Yep.
With probabilistic machines, which is what we're dealing with generative AI, they are working on statistically probable answers, which is analogous but not exactly the same to how humans work. We have experience, we've been exposed to information, and we think that based on my experience and the information I know, this is probably the answer, and that there is a level of interpretation there. I don't want to get too deep into the rabbit hole of the differences, but I think that level of analogy is useful in the sense that we have to admit that there is, with us and with the machines, there's an amount of interpretation. There is the possibility of error in recall. So, how do we build a process that caters for that?
Yeah. So I'll just touch on one point, and this is important because organizations are composed mostly of humans, right? Of humans and some technology. And then we've got processes running on top of these two. I think one very important thing when humans work with humans is that we've got theory of mind. We know we have some expectation of what our counterpart or what the other human in the organization with whom I'm interacting, I have some expectation of what they would know or what biases they might have because of their background, because of their education or whatever, right? So we actually self-correct based on our expectation of the answer, right? So if I tell you something, you respond and I say, okay, why did not respond this way? Okay, this is the reason. And so then I can correct my assumption based on that, right? And it's very
Yes.
important. Like most of the processes if you look at how real organization they operate, there's not just step by step. Most of our processes are not that much deterministic that we've got step A, step B, step C. We can write them down, but actually, if you look at the organization, that almost never happens like that.
Yeah.
So
Even within step one, within step two, there's lots of human agency, there's lots of human
yeah,
decision making. So
yeah.
it's that the granularity of computer steps is extremely refined and exact. Take this string of letters and put them over here. That's not how you write human processes.
Yeah, and so that's with computer. And so with computer, with standard programs, we expect them just not to fail, and so we give them very strict guardrails, and we say, okay, you are responsible for extending in Excel from cell A to cell B, and we're good. You asked about, okay, so what do we do with those failures and with the places where we understand that there is a problem, right? And it might be slightly controversial, but I would say you need to understand what the probabilistic AI, LLM based machine, what it actually does in this spot, right? Because we don't have theory of mind of the machine, right? And or
Theory
theory
of
of
artificial
or
mind.
theory of artificial non-deterministic processes or probabilistic processes that are going on inside the model.
Sorry to cut you off. I just wanted
Yes.
to define the term theory of mind. So, if those are unfamiliar with the term, theory of mind is your understanding that there's another mind, and understanding that that other mind is not seeing necessarily the same facts and the same world that you are. They're seeing it from their perspective, and so you can understand that they're different than you and think, okay, why might they be saying this? And for example, every time you're in a conversation, you go, maybe I'm not being clear. When someone else is speaking, and then you see them respond, and you go, this response doesn't make sense to me. And you can reflect and go, oh, maybe I didn't phrase my question properly. That's theory of mind. So however you want to refer to it, we are developing a sort of theory of, we need to develop, if we're going to be using AI, a theory of how can these AIs fail, because it's not quite like us, but it's similar in many ways. So there's a sort of a new theory of, I like the term theory of artificial mind, but that's, even though that's a bit inaccurate, but that's the kind of concept, getting your head around what could these things be doing and why might they be doing that, getting an intuition for that.
And the nice thing about this is that first, the more we use machines in our processes and the more we use AI or LLM based AI in our processes, the more intuition we get. But it's not just about it. I think that this is very important that we can employ statistics on top of the responses that we're getting, right? And this is we actually have because with a person we can't read or we usually don't collect all the outputs, etc. And with an agent that operates as part of the process, and we see that the answer does not conform to what we want. So we said, okay, let's evaluate. We've got an eval. We know that the evaluation is not passing, or in some cases. And then what you can do is you should be collecting the logs. You should be collecting what were the inputs, what were the outputs, and then start analyzing that, right? And this is, by the way, this is why we employ in our team, for example, we've got about 30 data scientists. So the data scientists are there, among other things, in order to understand what is going wrong. And then you need to start tweaking, right? And then, as I said, you either tweak in a very simplistic way. You either tweak the input data that you provide, and the input data could be your RAG setup, right? And maybe something is going wrong because the retrieval from your documents is just not working right. By the way, this happened to us so many times when we designed systems that essentially were supposed to help, for example, with financial analysis. If you are searching within a document, within a set of documents, you get 10 top 10 results, right? But if your sorting algorithm is not very good on these top 10 results, you actually want to resort and surface the right ones and the three results to give to the machine. Now, quite often, this part is not working well. So this is one mode of failure. And then you need to understand that the reason why it fails is that actually didn't get the right information. We think that it got the right information, but it actually didn't retrieve it. It has somewhere in the database the right information or in the set of documents, but it hasn't retrieved the right ones into the context of this particular conversation. And as opposed to humans who have some vague recollection, actually much worse recollection than the machine, but they have some vague recollection of the body of the documents that they're responsible for. So this is one option to look at. Second option to look at is potentially I was not clear with my instructions to the AI in the way that AI understands it. So again, you tweak your system prompt, so you tweak your context in order to make the system better. And as I said, that's also an alternative, and I think this alternative is usually underexplored but must be explored more and more, is how should I be changing my process? And maybe I'm just not using it in the right place, or my process actually does not require in this place, or I could restructure it such that the 80% is good enough, because this is exactly the point where I'm going to be introducing human in the loop. And then with human in the loop and the person that is going to be reviewing the answers, there's also a question. Is this going to be somebody who was supposed to be the next one in the chain of the process? Or maybe I can re-engineer it and say, okay, actually, if I'm working with customers, maybe with good UX, I could push the customer to choose the right answer and, I don't know, present three answers, and then it would be clear for the customer which one is the right one, right? So as long as I'm doing that, then I'm good. And then there's more complications that you could, of course, drive on the AI side. So have more than one AI agent, and these are the architectures that are currently starting to emerge, where we've got AI that is checking the AI, and that's why we've got increasingly complex agents. Again, but I would not go there before I've explored simpler opportunities, right? It's always start simple and then try and do things differently completely, and only afterwards.
I feel very happy to hear all that. You mentioned system prompts in there. I want to jump in there,
Yeah,
first of all, because I agree that it's so important. System prompts and context were two
yep.
terms you mentioned. So we're doing a lot of work where we've developed a modular system for organizing how you give AI instructions. So if anybody's familiar with the DITA standard, it's like a DITA for AI. How do you set context for multiple AIs who might be working together? So it might be the same underlying product. For example, we're working with this engine, this model, that model. But you're going to be defining roles within that. I am the data analyst, I am the
Mhm.
financial analyst, I am the writer, etc. So what I'm seeing is a lot of users will just treat the AI as the magic genie.
Mhm.
I will ask my question and my answer should come out. But when
Yep.
we're doing this in business, the term system prompt refers to setting up some set of instructions that define how a particular part of the system is going to work. And a key part of that is context. So when you say act as a financial analyst or act as a writer, you're setting some sort of context. And then you can put whatever more details you want in that context. And we do things like we have templates for saying, this is how you write a context, this is how you write an interaction framework. So when someone says this, you do
Exactly.
that. If somewhere in instructions I use quotation marks, this is what I mean by quotation marks. You should repeat this exactly to the user as opposed to coming up with your own answer. If I use this kind of brackets, I mean this. So in the same way that you would be setting up with a team, you would be setting up a writing guide, a style guide, standard operating procedures. You're writing operating procedures and style guidance for your AI to say, when I tell you this kind of thing, this is how I want you to react. If someone says this, you do that. So these kind of, and then also, this is where you fit in the role of the other AI agents. So if this agent sends you this, then do that. So that setting up the whole workflow and the workflow design is something that is where we went straight to at the beginning. Like The minute ChatGPT came out, we're like, okay, first thing we need to do is get away from just chatting with these things to defining workflows, defining the roles within the workflows, giving them each of those roles an interaction framework, context, what knowledge it's supposed to have access to, what skills it's supposed to have, et cetera, et cetera, et cetera.
Hmm.
And then you can analyze each bit of the workflow in isolation. So you can say, is it failing at the writing stage? Is it failing at the data retrieval stage? Is it failing at the et cetera stage? And also, I think you can explain it better to your human users.
Yep,
So when you
correct.
want this kind of task, go to this virtual agent. When you want that type of task, go that. And you can do all of that before you get into the whole complications of agents checking agents, blah, blah, blah. This is not a technical thing. You can do this with any out of the box model. And I think that what I'm seeing is a disconnect in the marketing. And I know this isn't like you're not under your
Hmm.
control, but what I'm seeing
Hmm.
in the disconnect in the marketing from the vendors is they're selling the genie
Mm.
instead of selling the business process approach. This is an amazing opportunity to re-engineer processes with human agents and artificial agents working together in re-engineered workflows. That is such a compelling, amazing pitch for business. But what I'm
Yeah.
seeing is this is a magic genie, ask it whatever you want and wonderful stuff will come out.
Yeah, I'm not in sales and I'm not in marketing. We're actually building the genie, but I think yeah, I think you're absolutely right. And by the way, it's also a very interesting sort of dynamics in the market of, the market is moving very quickly. How we're working with is evolving. We all collectively are starting to understand better and better what works, what doesn't work. I think it takes time for I don't blame the salespeople or the people in the field that don't necessarily have that because part of this is it takes time, right? And
Yeah,
actually specialized consultancy is something that probably is bridging some of that gap, right? Because it's not a sales motion, right? Their job
yeah, yeah,
is
yeah.
eventually to sell. And then, yes, you hopefully don't leave your customer with a bunch of, okay, here's some nice shiny toys, and now go ahead and implement. But quite often that is what is happening in any software, right? It doesn't matter whether this software is advanced software or otherwise.
Yeah, in their defense, this isn't new to generative AI. I've been in this industry for a quarter of a century, and
Yep.
every new software package is always the solution to all your problems. Basically, that's the summary marketing pitch for every software sale I've ever seen in my life. That's how it works. Just about everything else, just about every product is it's a new magic thing that's going to make your life better. And then also, it's what the customers want.
Mm.
So it's not like they're going in with this kind of perspective and the customers are coming in resistant and skeptical. Going fantastic. Finally, the magic wand I've been waiting for. So it's the AI hype cycle is just regular tech hype scaled up. It's the exact same thing. So
Yep.
I don't want to overly pick on the AI sales and marketing teams. But let's go into the when and how to go deeper. So how do we address this? So we've addressed we need to think about the workflow, we need to think about how we instruct more carefully, build
Hmm.
processes. When should we consider, for example, AIs checking AIs, or when should a business consider training their own model versus an off-the-shelf solution?
Yeah. So I think, as we said, it's like when things are continuously failing and you have realized that just tweaking things on the level of the one agent doesn't work. And then when tweaking on the level of re-engineering my process completely doesn't work. So you first need to go through these motions. By the way, there's for some reason, I don't know why. Maybe it's from the early days, like 2 or 3 years ago, when people started fine tuning, I hear so much from different executives and even techie people also saying, okay, let's just fine tune the model. It's going to be great because we've got some data and we're just going to teach it through fine tuning. This is kind of one of the ways to affect the models, right? For those that don't know what fine tuning is, it's providing its retraining or additional training on top of an existing base model. This sometimes can yield very good results. It's actually pretty difficult to do right. It's easy to just throw training data, but you need to have good evaluations in order to understand whether this actually resulted in better results really on your processes. It's not very cheap because usually the fine-tuned models are more expensive to use afterwards. But for some reason, it's like a go-to for everybody because people feel that if they fine-tune the model, then they've got a unique piece of IP in their hands because they now have a model. Just OpenAI have a model. Now we've got a model that is OpenAI model plus some delta that is our particular model, and so I think that there's this parallelism that people think, oh, if I've got my own specialized model, that means that I've got some unique IP, but actually your unique IP could be in other places. Like you said, setting up a really wicked, strong system prompt for your machine is actually very important, right, for your agent. So the IP can lie in different places, not just in fine-tuning. So coming back to your question, okay, when do we go? It's like when other modes have failed. So then we go to further complication. I think that checking the checkers with the eyes, I would go there right now. The frameworks have matured and are continuously maturing, and these are relatively simple engineering frameworks before I would touch on fine-tuning. Now, when does fine-tuning make sense? In our group, we have fine-tuned quite a few different models for different goals, both by ourselves as well as with some partners from the outside, partners who are leaders in the industry. And what we have done, so the reason to fine-tune is to find a better place. Usually it's find a better place on the trade-off between cost and quality, right?
What's the cost difference of fine tuning?
So let's cover a little bit about which models we've got in the market. I would separate models into two parts. There's large language models and small language models, right? So large language models have hundreds of billions of parameters usually. Small language models have, I don't know, typically up to 12, 15 billion parameters. That means that they require significantly less compute in order to run them. So they are cheaper to run. They require less memory because they're smaller, so they can fit in a smaller machine as well. And they are both to run and to develop these models is usually easier. To fine tune a smaller model is much easier and cheaper than to fine tune a large model. So what you could do is you could have now small language models. They're not as accurate. They're usually not as, I'll use the wrong word, but they're not as smart as large language models, and they usually cannot reason in the same way, etc. So we've got a model that are small language models, and if we want to significantly improve a small language model, then one of the approaches is to add more data and to continuously fine-tune it and fine-tune it more. And then you would get, for the price of running a small language model, you would get something that is specialized to your use case. If you've added information that is relevant to your use case and some proprietary information that you've got in your organization, something that you have that is your own, then you might land in a better place on the trade-off between the cost that it costs to run. So any address to that model would not cost, I don't know, 1 cent, but would cost 0.1 cent or even less. And that is sometimes a competitive advantage. Now, again, personally, I would strongly caution before going into this direction. The reason is that, again, from our experience only is, so there's a number of reasons why not potentially to go this way. First is that advantage is not durable, right? The world is moving all the time. New small language models are coming out. You're better off, waiting for the next small language model, and then you're going to need to anyway fine tune that one. So you're actually, once you fine tune the model, it's not and then done, right? So this is one thing that is happening, so that new things. So if you fine tune the small language model, you're going to need to also fine tune the next generation of that small language model and the next one.
So you can't just upgrade the underlying model once you fine tuned it.
You cannot upgrade the underlying model. No, you can't. You can't. So there's something called LoRa. Anyway, there's ways to fine tune, but these are, I don't think, ever transferable between one model and another model. So you can't just take those adjusted weights and just transfer them to another model.
It's like heavily customizing a piece of software. If you over customize, then you've bought yourself, you've got your thing, but then you're now locked out of the future of that.
Yes, exactly. And so you would need to re-customize, and so you would need to re-fine tune the new model. And potentially, hopefully, you might be able to use the same script, etc. But still, that means that every 3 months, you're going to need to have essentially a team of data scientists that are going to be doing that every 3 months, running the script, running the evaluations, checking whether the model works correctly or not, hoping that the architectures of the underlying models are also changing all the time. So actually, it's usually not even the training is not going to be just a lift and shift, right? So this is one thing to consider. Second thing to consider is that the price of the large language models is dropping continuously. So we had a case, I would say it's all has been pretty recent. I remember that we trained a model last July or thereabouts, and then the large language models, actually GPT-4o in that case. So I think the price dropped almost tenfold. And so the price differential that we used to have, that our small language model was trained and was at the point cheaper than GPT-4, great. But GPT-4o suddenly is 10 times cheaper and is performing at the same level as the large language model is costs essentially the same as my small language model. So that's the second reason. Third reason is that usually serving small language models also is it's a chore, right? It's usually not just hitting an API because you might be able, it depends on, there are providers that allow you to fine tune a model just by throwing a little bit of your own data in a particular structure, and then they do the whole fine tuning process for you. But if you're doing something custom, then you will need to think about, okay, how I'm going to be hosting it, how many GPUs do I need, where do I get my GPUs? We know that there's quite a lot of shortage. So
So
actually,
the technology
DevOps,
infrastructure,
the
you're getting
technology,
yourself into a lot. You're
yeah,
buying an elephant, is what I'm hearing.
yeah,
So you're getting yourself into a lot of work, and I think you're also referring to something which I see all the time, which is, so for example, had a lot of talk about the six finger problem on the
mm,
photos, and I work a lot with the content industry, and a lot of the content people were very quick to just kind of laugh off the
mm-hmm,
output of AIs because it was generic, and we had the writing equivalent of the six finger problem. It was
yep,
either widely inaccurate or just terrible writing, or
yep,
both. But I think humans were not cognitively structured. We're not ready. We're not evolved to deal with things that happen on an exponential curve.
yep, yep,
So the difference in 18 months is so drastic, so night and day, that it's hard for us to believe. We look at that and go, that's blah. What's going to be, that's how it is. And then you go back to your work and you go back to work, and a year goes by, you turn around and the world has changed. So I think that riding that rocket is going to be, that's a whole mental model shift of
yep,
the speed of change, which I don't know how we're going to adapt to, but I'm trying our best to address that one.
yep.
If were you on your last point there? Because I want to
Yeah,
also.
let me just one more point. And by the way, your example around the six fingers, etc., is actually also very relevant because one of the things that people have done is they fine-tuned models in order to get rid of the six-finger problem. And then 18 months ago, some people have done the work to actually improve significantly and then invest the time in making the six finger disappear. But then comes
Did I define what
obsolete
the
with
six finger problem was?
maybe you have.
I don't think
Yeah,
I don't think I did. I
go
think so. The
ahead.
six finger problem, if we all remember, when the image generators first came out, that they couldn't. It's we say the six finger problem, but could it be the three finger problem or the 11 finger problem?
Yep.
But that we just couldn't get the hands to come out when you generated pictures of humans. When you create a picture of a bee or a tiger, maybe you didn't notice. I remember I used to generate pictures of insects all the time, and they look great to me because I don't know how many little things are supposed to be on their heads anyway. But when it's human hands and faces, we were extremely sensitive. So teeth, eyes, fingers were very difficult for the machines to get exactly right. Then it got faces perfect because there are trillions of faces on the internet, but not actually that many good, useful examples of what hands are supposed to look like.
Hmm.
So it was a tough problem. And it took a couple years, which is a very long time in AI time. But from popularity to really perfecting human hands, did take less than 24 months. And so it's a kind of a reference problem about how everyone was giving conference presentations going, ha ha ha, look at these things that they call intelligent, they can't even get a hand right. And so what you're talking about is about investing in a model and going, okay, this model costs X and there's an ROI and blah, blah, blah. And then you train it. And then by the time you're finished and roll it out, try to start getting some ROI, then your whole business case is gone because
Exactly.
the underlying problem which you were trying to fix 12 months ago has just vaporized because the problem has been fixed.
Yes, correct. Just one last piece on this fine-tuning problem, and then we can move on. Because I think it's also important to say when it does work, right? And when you should. And I think
Yes.
so you should invest. And I think this, again, from our learned experience, is that in places where you need something that is extremely specific, and the more specific the task, the easier it will be to evaluate, the easier it is to find the right data rather than just throwing everything at it. And then this particular task could be, for example, named entity recognition. So today's models, they're great at named entity recognition. We already have that for 20
Which is, can
years.
you define that?
So named entity recognition is recognizing concepts within a particular document or a particular text, right? So that could be recognizing the name of a place. And then you would be able to tag, okay, this is Madrid, this is London, this is Tel Aviv. So you can recognize and say, okay, this is a city. Or you could say, this is a country when you're talking about Israel or Spain or England. And so recognize, so this is called named entity recognition. This is a very old problem in machine learning, in classical machine learning, and classical natural language processing. And now the big models are pretty good at this, but you actually can train a small model that is going to be amazing at it for your particular set of entities. And if your entities do not exist much on the internet, right? I need to recognize the names of machines on the manufacturing floor, right? And I need to know whether this is a machine on the manufacturing floor or whether this is a brand of sneakers that I'm wearing. So you could discern between the two very easily, and you could train a small language model that would be doing that and would become specialist in this. So look, if you do get to a problem where, for example, some particular task is failing and where you have proprietary data and that is a very particular thing that you want to fix, that is not a generic thing, then yes, that might be the place where you might go and get good ROI on fine tuning.
I have to address that example because I know that some of my audience will be going, but we were doing that with what we call auto taggers far before the generative AI movement. So why would, not to extend this portion, but
Mhm.
why would I use a generative AI to do that when other machine learning tools that we've been doing that with taxonomy and graph tools to do that auto tagging for, I think, easily a decade. So why would a generative AI be a good thing? Can you give another example of where fine tuning might be good with
Um,
generative AI? I think that's probably
yeah,
more useful.
yeah. So I think that I'll answer your first question as well. The first question is why would you do? It's not necessarily the best tool, but it's very versatile. You don't need to train for a particular entity instruction. You don't always need to train. And so this is actually very easy, and quite often the results are significantly better than the old generation. They're also more expensive, but they're significantly better results. So this is one thing to notice. Now, where else fine-tuning was very useful? Again, in recognition, so one of the projects that we've done is recognition in agriculture, recognizing crop diseases, right? So that was an image processing model, and then we fine-tuned that image processing model to recognize the different diseases so that a farmer would be able to take a photo of essentially a crop in their field and then get the response, okay, the it's being afflicted with this parasite or with this fungus, etc. And therefore, you need to have this chemical in order to treat it away. So that these things, it's like they're not wildly available on the internet. It's
Mhm.
proprietary data to agricultural companies that have enough training data for that. And the task is very specific. I need to recognize one of 150 diseases. I don't need much more. It's like just choosing between one of these 150 when the difference between them is quite subtle.
So it could tag it for you. But a large language model would be able to read through many call logs, and if you had trained it on, for example, your device's particular faults, your
Yep.
common failure modes, etc., or you're the only manufacturer in the world who makes your product, you're the only one who can take photos of what the engine looks like or what the battery looks like when it's leaking, etc. So in those cases where you're doing more interpretation or recognition, that's not just what an auto tagger does, but
Yep.
maybe saying, okay, if they've taken these steps and it's been this result, then it's probably this error
Yep.
or something like that. That would be something where you're training on very private data, but to do a
Mm-hmm.
very specific task, but you need more than just tagging it and saying
Yeah.
this was mentioned, that was mentioned, the other was mentioned,
Yes.
but actually understand tracing a series of steps and coming out with kind of a conclusion. Okay. All right. So now I got particular clients flying into my mind now, which
Hmm.
and so for the next question that takes me to, and I think generally for my audience, a lot of people are always very interested in. We got a lot of content people in the audience. How to prepare and format our content, aka data, aka
Hmm.
documents, for AI.
Yeah.
So I think I have found in practice, you can throw heaving PDFs and PowerPoints into it. However, you get better, more consistent results if you do some pre-preparation on your content. What are your thoughts on that?
Yeah. This is absolutely true. Is that you can, let's talk about how usually or naively people implement retrieval augmented generation. What is retrieval augmented generation? I've got a pile of documents and then I process them. I essentially measure, I chunk them into small chunks, and then I measure the how similar the different chunks are to each other, and I embed them. I explain, I essentially say what they mean. Okay, this is in machine language. This is a very rough explanation of how things go. But then I've got a pile of disconnected chunks of documents that are roughly, and I'm saying, okay, roughly this paragraph is talking about, I don't know, politics in Eastern Europe. That kind of, it's like more or less, yeah. And it has some people mentioned because I'm embedding those documents in a what's called multi-dimensional space. I'm doing this actually by processing them with a language model, but rather than generating something, I'm generating just the embedding vector, just one representation of that document and then or that chunk, and then I've got multiple of these. Now, this is the naive approach, and then when I'm looking for some information,
So
or I
the
want
approach is
my
just is sorry.
yeah
Summarize what the approach is. So that you understood the situation. You've got all these different
yeah
documents. So
Yeah,
what is the
and
approach?
you chunk them into smaller portions, and then you take each paragraph, let's say, and then you essentially say, or in machine language, you say this is roughly about something, about a set of concepts or a set of semantical entities, if you want.
You tag it essentially.
It's essentially you tag it, but you don't tag it in a way that you could say exactly, okay, this, you don't you don't tag it to a particular concept, a single concept. You are
Okay.
tagging it to a conceptual space, right? What do I mean conceptual space? You're saying if I've got, let's say, a paragraph that talks about the recent election fraud in Russia, then it will be somewhere close to a different piece that is talking about Putin and his cronies. Because the topics are somewhat related, right? So I would be, or when passing it through large language models, the naive approach, the usual approach is just to say how similar semantically these two parts are, but it doesn't
Mhm.
talk about concepts. And that is, I think, so there's two levels of complication or further complication that you actually in order to prepare your data. So the most naive way is just understand more or less what this talks about and then chuck it into one large pool of documents or paragraphs even. And then when the model needs that data, it will search through what is most similar to follow and pick up the right or not the right, actually pick up some documents from the large pool. And that is you very often don't get the right information in this case, and you might not get the right context. What I mean by the right context, because a paragraph about, I don't know, election fraud in Russia, actually, it's very important. Where does this paragraph come from? Right? Is that a critical piece or is this a propaganda piece? Right? And actually, the context of the overall document in which this same paragraph might have exactly the same words, but the context, the wider context of the document is very important. And so, on the most basic level, you need to connect the other pieces of the document, right, to the piece that you extracted. And this is where we get into what we call graph representations, right? So representing the metadata of the concept. And this is the most basic implementation, right? So the first thing that I will do then when I'm trying to retrieve some information, I will embed each paragraph, but then together with this paragraph, I'm going to also pull into the context of my model, of my agent, I'm going to also pull the other parts of that same document, right? So at least let's not lose the structure and the fact that it exists as part of a larger whole, right? So this is first level where we want to have the concepts, or to have at least the concept of the document and the metadata concepts pulled together with the data. And then a more complex and usually even better approach, which allows us to actually start talking about concepts and pull in documents not just based on the semantic similarity, but based on conceptual relevance. What do I mean? That if I am putting out a document about Russian elections, I'm sorry to use that one slightly political example, but if I'm putting that one out, is I would actually also want to pull out potentially information Putin himself, right? And about Putin as a person and anything that is related to Putin as well, right? And so you would be pulling in together, right? You would want to have a concept of a political figure, and that political figure happens to be a particular individual, so Vladimir Putin, and then you want to pull in other information that is related to that, but is not directly semantically related to your paragraph that talks about the election, but you want to pull in known associates of Putin. I don't know, his spokesperson. You want to pull in additional information in order for the model to be able to reason about a wider picture and the wider context. And this is what we call essentially knowledge graph or knowledge graph based retrieval. By the way, people quite often talk on the web about graph RAG, okay, graph retrieval augmented generation. There's a lot of flavors of it. Some of them are metered. I won't go into specific details, and I think it also requires examination of the specific methodology that is needed for a specific use case. But generally speaking, what you want is you want to pull information not only based on semantic similarity or not based on verbal similarity, but also based on conceptual similarity.
Can I jump? I want to jump in there because you're mentioning different types of graph rag. First of all, so the knowledge graph itself. So we're bringing that term up, which
Yeah.
is our type of database, which is not in the AI model, not in the language model. This is now something that the language model is speaking to. I think that's important to make that distinction. So there's a couple things. First of all, the original question was about how we prepare our documents. And
Yeah.
you've gone into how we talk about the graphs, which was I was going to ask about in one as my next question. But as long as I would like to get back to the documents, but as long as we're on the graph, I don't want to get too in, I don't want to do a technical deep dive, but that there are different types of graph. Not all graph databases are the same, just like not all databases are the same. So certain graphs will be better at making complex deductions or analysis, looking at different factors. For example, I've got clients who absolutely do not want popularity-based answers. So if you go into certain types of graph, the same way that you go into certain types of search engine, it's an essentially popularity contest. Based on the words you've given, here's an answer which is the most popular in the system. Customers also bought, or on Google, other people also asked. You're basically traversing a set of popularities. I have lots of feelings about this, and we'll talk about that on the Truth Collapse podcast, about how that is very useful for some cases. But I have a lot of customers who, we were talking about the six-finger problem, they have the three-legged elephant problem. The three-legged elephant is something that I was using as a test for image generators. There's also examples like image generators could not generate a full glass of wine. Or if you ask it for a watch, the time is always the same. So you can't get it to give you a watch or a clock where the time is set differently. I think it's specifically watches. Watches. Because all the watch manufacturers, aesthetically, it's pretty if the hands are in a certain position. If, for example, if two of the hands are overlapping, it's not a nice photo of the watch, so you don't want to sell a watch with a photo like that. So
Yeah.
like the vast majority, like 90% of the watches I've ever seen, the time is always set more or less to the exact same time. It's a sort of an
Yeah.
industry standard. And so what you have there is you have a popularity problem where, yeah, most people like it like that, but that's not what I asked for. So if I have a customer who has machine-specific content or customer-specific content or a version, like a mixture of versions, and I said, I want to know if I'm using this product and for these 10 modules, I'm using versions A, B, C, and D, I want to know the answer for my situation. I don't care what other people have asked. I
Hmm?
want you to go look up the different products, look up their different version possibilities, look up what I asked in that context and only in that context. So if I asked you for a picture of a three-legged elephant, I don't care if you've ever seen a three-legged elephant. That's what I asked for. So I think that when you're talking about types of RAG or types of database or types of back-end system, to be the most general and
Yeah.
simple, when you're talking about the back-end system that is going to support your language model, you have to take into account, does this thing really have to understand the problem space, understand the data space, and be able to deduce something? Or am I looking for what's probably correct based on the number of times it shows up in the database or the number of times other people have asked, which are very different things. It's
Yep.
very different to say, I want a needle in a haystack, regardless of what other people have asked, or I want what's right based on these other parameters like popularity or a number of appearances in the database. So I think that question is very important to get right at the beginning. And I'm
Hmm.
literally seeing customers spend millions racing into, yeah, we'll put the stuff in, we'll run a training run, and it'll give people what they probably want. And the word probably is very powerful, and with that power comes great responsibility. So I
Yep.
think that I wanted to highlight that challenge, and that you need to look at what approach is right for you, and even if you need a hybrid approach.
Yep. And then most of the things have a kind of a hybrid right now. So it's not just a knowledge graph and extract from a knowledge graph or only extract from a vector database with similarity. I think one important thing that you said, and let's come back to this for a second here, about getting or organizing your data landscape correctly, right? And how do you organize your data in order for it to be afterwards useful? And I think that this is such a huge problem and such a multi-layered problem that hasn't yet been, I don't think anybody has really solved it, but I think organizations must start solving it and probably continue solving it for the next 5 years at least, probably more, but we can see. Because right now, the way that organizations treat data is they treat it as a set of heaps. People like to say silos. I'm calling them heaps because it's like you've got a heap of data in a particular SharePoint, in a particular, etc. Then you've got some databases that hold some information. Then quite often there's no cross-organizational understanding of where the data sits and what is that data actually is, right? You've got a set of documents there, but there's very few people who understand what documents are these, for what purpose they were collected. So you don't actually have this metadata map, right? So you might have gold in your, as the analogy that I'm usually giving is that you've got a dark room where you've got heaps, and then in some of these heaps, you've got gold nuggets. That's great, but the room is dark, right? So you need to, first of all, switch the light on. Switch the light on is understand what the different data, the data piles that you've got, understand what is in each one of them.
Yeah, and also that one person, what I was getting into earlier, that one person's gold is not the other person's
Correct.
gold.
Correct.
So I really like this. I'm delighted to hear this because one of my biggest frustrations right now, as I referred to in the beginning, is this kind of rushing in and going, okay, the genie will find the gold for me. So to have you validate that, I think is fantastic. That we don't know what we have, we don't know how it relates to itself, and then thinking back on that particular client, that one of their points is we keep everything. By definition, 80% of this is out of date. Sometimes people want the latest, sometimes people do want a historical view, but if you're looking at it by raw probability, probably you're going to get an out of date version because there's more out of date versions than there are current versions by definition. If
Yeah,
you've
that's a
been if
very
you've been
interesting one. By the way, I'm running into this problem constantly. So these days
out
I'm
of date,
writing.
wrong.
Yeah,
Out of
yeah,
date or simply wrong.
yeah.
There's
And
lots of incorrect information written down in our documents.
And it's not just written down. Let's not forget. It's like very simply. So I'm using, it doesn't actually matter what I'm using. I'm using Gemini, I'm using Perplexity, I'm using ChatGPT, I'm using Copilot. I'm using all of them connect to the web in order to get information. And then I'm asking right now, I'm looking to actually for my own pet project, I want to understand which library, Python library to use for my coding project. And so I'm asking, okay, does the library do X, Y, Z? Right? And quite often it would go and search for some sources on the web that have reviewed that library or have reviewed that product. If I want to use that product, they have reviewed it, but they reviewed it in 2012. The web is pretty old, right? And then there's, okay, in 2012, it was not yet able to do it, but there's, as you said, there's plenty of old information, and the sorting algorithms, the search and retrieval algorithms, they do not have the sufficient understanding of the context of the information. And the context of information is that actually it exists on a time scale. And so for my use case, it needs to be the most recent information to be presented first. So that understanding does not exist naturally unless you bake it into your product.
Excellent. Okay, I think you and I could talk indefinitely. So I think we do have to wrap up. I think that there's a lot of gold and nuggets in this conversation. I'm glad that we got to
Yeah.
talk to both Rag and a lot of the realities. I'm so happy that you've been able to speak plainly and clearly about both the power and challenges of AI today. So I want to thank you for that. For those of you who are interested, we did talk about the dangers of just a probabilistic algorithm. And Ilya and I have talked extensively, both in person on LinkedIn, about some of these other issues about how throwing popularity algorithms over things, and also now in the generative AI space, when we are having generative AIs who are going to become creators of content and anthropomorphized active agents in culture is what I call them, because we had an algorithm choosing our cultural interactions for us based on popularity, that already had huge impacts. And now when algorithms will be generating cultural artifacts and being participants in these cultural conversations, we are essentially supercharging that challenge. So we're going to jump over onto the Truth Collapse podcast and talk about that in a bit. So you can join us over there. But I want to thank you again, Ilya, for all of
Thank
your
you.
knowledge and contributions today. My final question is, do you have any other people that you think our listeners
Yep.
should follow, or any other books or resources that you recommend that would help them learn about some of the things we talked about today?
Well, that's so much. And frankly, I am consuming most of my information diet, and we can discuss about that, but from people whom I follow on LinkedIn. So a lot of the thoughts that I'm having are, for example, from Ethan Mollick. He's a professor at Wharton, and he wrote a book. It's called Co-Intelligence, actually how humans should be working together with machines. Super interesting. I think he's got very good, strong takes on what technology can do, what technology cannot do, how to operate together with it. So definitely follow him. I think he's one of the better thinkers out there. Stuart Winterter, another person also on LinkedIn, and a friend who's writing a lot about the practicalities of building with AI and how to think about business problems from that perspective and from a product lens.
Can you say that name again?
Stuart Winterter.
Wintertime.
We
Okay.
can
All right.
put it in the comments afterwards.
I will put that in the show notes. Fantastic. Okay. Thank you so much, Ilya. That was awesome. And we will see you over in the Truth Collapse podcast if you want to join us there. Thanks,
Yeah,
everybody, for joining, and we'll see you next time.
thanks.